In a paper published in Nature Genetics in 2017, reported that after analyzing tens of thousands of genomes, scientists had tied 52 genes to human intelligence, though no single variant contributed more than a tiny fraction of a single percentage point to intelligence. As long ago as the 1970s, David Baltimore, who won a Nobel Prize, questioned whether his pioneering work might show that the differences between people are genetic differences, not environmental differences. Genes contribute to intelligence, but only broadly and with subtle effect. Genes interact in complex relationships to create neural systems that might be impossible to reverse engineer. In fact, computational scientists who want to understand how genes interact to create optimal networks have come up against the kind of hard limits suggested by the so-called traveling salesperson problem. In the words of the theoretical biologist Stuart Kauffman, in The Origins of Order, 1993, the task is to begin at one of n cities, travel in turn to each city, and return to the initial city by the shortest total route. The complexity rises to new level, especially since proteins and cells interact at higher dimensions. Importantly, genetics research is not about to diagnose, treat, or eradicate mental disorders, or be used to explain the complex interactions that give rise to intelligence. We won't engineer superhumans anytime soon. We have known for a long time that 30,000 genes can't determine the organization of the brain's 100 trillion synaptic connections, pointing to the irrefutable reality that intelligence is to an extent forged through adversity and the stress of a developing brain.